Hello everyone, my name is Alvaris Kiwayudi. I'm student at Polytechnic State of Semarang. And today I'm excited to present my biggest project named Monitoring and Controlling Hydroponic. In this presentation, I will discuss how IoT technology can be used to effectively monitor and control hydroponic system. I will cover the background of this project, the components involved, and the result achieved. The background to why this project was created begins with the decline of agricultural land. As the population increased and cities expand, agricultural land decreased. Much agricultural land has been converted into housing, factories, and roads, reducing the space available for agricultural land. Additionally, poor agricultural practices such as excessive use pesticide and planting the same crops repeatedly have degraded soil quality. This makes it harder to produce enough food for everyone. To overcome the shortage of agricultural land, hydroponics emerged as an alternative way to grow plants without soil. Hydroponics is a method of growing plants using nutrient solution in water. Traditional hydroponics include simple methods like NFT. In NFT, a thin film of nutrient solution flows over the roots of plants growing in a narrow channel. This method allows farmers to use space effectively and increase crop yields. With advance in technology, modern hydroponics has become more sophisticated and efficient. This system often use automation and sensors to monitor environmental conditions like pH level, temperature, and humidity in real life. Some of the problems frequently faced by traditional hydroponic farmers include tools. Farmers often lack equipment to monitor nutrient level in their hydroponic system. Without reliable tools, it is difficult to determine whether the nutrient solution is sufficient for the plants or not. Inadequate monitoring can have a negative influence on crop production and poor plant growth. Furthermore, the farmers can constantly keep an eye their hydroponic condition around the clock due to other obligations. This sometimes causes individuals to worry about whether pests are attacking their plants or whether they are thriving in inclement weather. The issues that have been found have led to the development of an Internet of Things device system that use a smartphone to remotely monitor and manage greenhouse temperature, nutrient level, and pH level. With the help of this creative solution, farmers can effortlessly monitor their hydroponic system and access real-time data from any location, guaranteeing the best possible growing condition for their plants. Farmers may increase crop quality and output by using this technology to increase productivity and make better decisions. The IoT device will be strategically installed inside a greenhouse to monitor a comprehensive range of environmental parameters that are essential for optimal plant growth. This advanced system will continuously track the pH level of the water, which is critical for nutrient absorption, as well as the total dissolved solid, or TDS, in the water to ensure that the nutrient solution is balanced and effective. In addition to monitoring water quality, the device will also measure the temperature of the water, which can significantly influence plant health and growth rates. By keeping an eye on the water volume, farmers can ensure that their hydroponic systems are adequately supplied, preventing issues related to over or underwatering. Furthermore, the IoT device will monitor the temperature and humidity levels within the greenhouse itself. These factors play a vital role in creating a suitable microclimate for plants, affecting everything from photosynthesis to transpiration rates. Lastly, the system will measure light intensity inside the greenhouse, ensuring the plants receive adequate light for optimal growth. To collect the data will be transmitted to the cloud and securely stored in comprehensive database for further analysis and reference. This cloud-based system ensures that the information is readily accessible and can be managed efficiently. Users will be able to access this stored data to dedicated websites or mobile apps, which provide a user-friendly interface for monitoring their hydroponic system in real time. Through this platform, users can view current reading of critical parameters such as pH level, nutrient concentration, water temperature, and environmental conditions within the greenhouse. In addition to the monitoring, this application empowers users to set and adjust threshold values for this parameter, allowing them to define optimal range for pH, nutrient levels, and ideal temperature. The threshold values set by user will also be stored in database, ensuring that these important parameters are readily accessible for future reference and adjustment. This storage capability allows for a seamless integration between user preference and the operational function of the hydroponic system. By keeping a record of the desired threshold value for pH level, nutrient concentration (TDS), and greenhouse temperature, the system can maintain consistent growing conditions tailored to specific plant requirements. Once threshold values are established and stored, the IoT device will retrieve this data to actively control the hydroponic environment. The device will continuously monitor real-time conditions and compare them against the predefined threshold. If any parameter falls outside the acceptable range, the system will automatically make adjustments to correct it, such as setting nutrient delivery, adjusting pH levels, or regulating temperature within greenhouse. After the system is created, the next step is to design the IoT device. The system consists of three main blocks: monitoring, controlling, and nodes. First, controlling block. Controlling block monitoring block is responsible for collecting data from sensors that track important water factors such as pH level, nutrient concentration, water temperature, and water volume. For the microcontroller use, there is an Arduino Micro as the main micro, and there is also Lilico ESP32 T-call as network switching. Network switching is useful when the area has a network quality that is difficult to predict. Therefore, this feature is very helpful to switch the network Wi-Fi or cellular network. During monitoring, there is also an SD card module is used as a system log storage location. With logging, it will make easier for developer for troubleshoot when a problem occurs. That method used to send data to cloud itself use the REST API method. Next is controlling block. The controlling block function to make adjustment and maintain optimal condition based on user-defined threshold. Use SP32 as the microcontroller and also has SD card as the logging system. To control pH and nutrient level, a small pump is used which will then provide nutrients or pH down according to target. However, there is a problem, namely that nutrients and pH down cannot be directly dissolved in water. Therefore, it cannot be read by the sensor after providing nutrients and pH. Therefore, a machine learning algorithm was created to solve this problem. Machine learning will predict how long it will take to achieve the target that the user has set. The machine learning model itself uses ensemble machine learning, which is a combination of several machine learning models. After providing this nutrient, within 5 to 10 minutes, the nutrients and pH tone that have been given can be immediately censored again. Last is node block. The node block functions as a sample for several crucial points in the greenhouse. The greenhouse points are points where temperature, humidity, and light intensity will be taken. These dots are usually placed on the part of the area where the plants look better than on other side. By comparing this point, the user will know what temperature and light intensity are optimal for the plant. Using ESP2 as microcontroller, this node will later be installed more than one in a greenhouse. So this is a floor plan of a greenhouse in collaboration with this research. In the greenhouse there are 14 plant tables. However, on some sites, plants grow less optimal than on other sites. Therefore, nodes are installed at several points of the table to retrieve data on temperature, humidity, and light intensity. With so many nodes installed, an optimal IoT network topology system is also needed. The first network topology created was a mesh network topology, where there was a gateway which will later be used as a data center before being sent to the cloud. There's a weakness in this topology, namely the lack of reliability of this topology is handling data from the device. Therefore, a new network topology was created, namely the star topology. In this topology, each IoT device will send its data directly to the cloud via an access point that is installed in the greenhouse. With this topology, IoT devices do not need to send their data to gateway first. In this way, the gateway can also be converted into a node with several additional features. In this project, I contribute to the hardware part of the IoT device itself, such as making the PCB pad, making the hardware system design, and also optimizing the sensor part. Not only that, I also as a programmer contribute as programmer to this project. I optimize it so that the program I create feel like to execute and not burdensome on the hardware side. Heat is one of the main enemies on electronic device. By making program feel like to execute, the device will be more resistant to weather at the same time. This project started in 2022 and I joined in May 2023. In this month, I continue to be active in doing coding research and also optimizing the hardware and machine learning use. This is what the monitoring device looks like if it's installed in a greenhouse. In this device, there are also displays that make it easier for users to see current condition without using smartphone. This is a controlling device which contains electronic device and also several small pumps. The pump is what is used to provide nutrients and also pH down into the plant's water reservoir. This research also collaborates with several greenhouse areas in Semarang, such as SMKN 1 Bawen, Argo Purwasari, Turasasi Greenhouse, and also Sandi Buana Farm. This is website for monitoring greenhouse condition. On this website, you can see several crucial parts such as data on water condition for plants, the time of the last data, photos in the greenhouse, and also temperature, humidity, and light intensity condition in the greenhouse. There is also data for installed nodes. Because there are several greenhouses that have collaborated in this research, an interoperability system between greenhouses was created, where greenhouse owner can see the condition of other greenhouses and also IoT devices that have been installed between greenhouses can exchange information between greenhouses. With this system, it will have a positive impact where if one greenhouse has good harvest result, other greenhouse users can immediately get information and try to put into practice the data that already exists in the greenhouse with better harvest result. If we choose a particular greenhouse, several data will appear that we can see, such as parameter setting data for temperature, pH use, and TDS fluid use. Not only that, the harvest results are also displayed in graphs that are easy for other greenhouse users to see. There are some documentary photos of the research team during installation in another greenhouse, such as Sandibona Farm, Argoporosari, and also SMK in One Bowen. That's the presentation about my biggest project. This project is the result of collaboration between Semarang State Polytechnic lecturers and Brian and is funded by LPDP. The ending of this project ultimately helps hydroponic farmers to solve existing problems and also invites the younger generation to become young farmers who are more aware of technology in the agricultural sector. That's all my presentation. That's all my presentation. Thank you very much and goodbye.